Time once again for some kitchen table astronomy at the Amherst Kitchen Table of Hampshire College and Kynott Studios astronomer Dr. Salman Hameed. First off, I saw the final Best Picture nominee for the Oscars at Amherst Cinema. Were you on the board yesterday? I'm still here. Wonderful film. One of our favorite TV shows, Shogun, cleaned up at the SAG Awards last night. Yeah. But we'll maybe save some Oscar talk for next Monday. We are going to remember an astronomer from here in the fabulous 413 who's passed.
Yeah, I want to mention the passing of George Greenstein. Professor George Greenstein, he was a Sidney Dillon Professor of Astronomy at Amherst College. He retired from Amherst College in 2012, but he was still active. And he actually was on the hiring committee, which sort of when I came here as a postdoc, as a 5-college astronomy department postdoc, and my position was split between Smith and UMass, but he was one of the people who interviewed me, along with Professor Susan Edwards at Smith College. And right from the beginning, I just wanted to mention, right from the beginning, if you say something that's intrigued him, he would sort of close his eyes and then think about it. And then there would be a smile on his face, and he would follow up with something really thoughtful, interesting. And for me, because I was, one of the things that I had to do when I came here was to develop a class on astronomy and public policy. Mm-hmm. This was a new type of class, and I think George Greenstein was part of, was the people who were, thought about this class, along with Professor Susan Edwards. And we had to meet, in my first semester, we would meet once a week at Panda East in downtown Amherst.
I love that, yeah.
So the two of them would be there. They're both sort of senior professors, and I was freshly minted PhD. So to me, every time it looked like that it's going to be a thesis exam. But it was just so much fun because the conversation was always interesting, and it's the thoughtfulness. And so when I would come over there, and I always wanted to, especially for George Greenstein, say something where he would close his eyes, think about it, smile, and then say, well, that's a good point, or something regarding that. And he was intellectually, he was always pushing the boundaries, not just from astronomy, in other fields as well. He actually wrote multiple popular astronomy books, including, I think, a textbook as well. But one of the books he wrote back in the early 80s called Frozen Star, and it was about black holes, pulsars, and other types of strange objects. And I had actually read that before I came to this area in 2001. And he was a great, thoughtful writer, but he was also a photographer. He had great exhibitions, actually great photographs and exhibitions in New York. But I think I also remember him talking about science and religion. I mean, he was one of those people really thinking about it. He was an atheist, and he would just bring up something. And at one point, I think there was a seminar on science and religion at UMass, and we were on the same table, and we were all going through sort of how we think about it. And his question was, and I still remember, I think this was back in 2003 or 4, and he says, I just want to know why this sack of atoms can just think about these questions. I mean, just why? And it was just it just was a great conversation starter. I mean, he was the first one.
And a sack of atoms meaning a human being?
Oh, meaning a human being, yes. But he was, I think, when you are talking to him, you always knew he was thinking about the question that you are asking. And you could also see that he's not presuming the answer. He actually is going to sort through the thing that you have brought up. And in some ways, you would run into him in downtown Amherst, and that's why always there will be an interesting conversation, because he was curious in what you have to say. Mm-hmm. And in some ways, he's a model, at least for me, because he remained active in these questions, in always smiling. I mean, so that was also, he was always very polite, but also be intellectually engaged and always be interested in questions. and I think that was such a wonderful thing. And so it's sad, like he passed away. I think this a couple of days ago, but a genuinely pleasure to know him when he was here.
Remembering Amherst College astronomer George Greenstein. That's right, right?
Yeah.
Who has returned to stardust, as many of us like to think of it. We are all going to return to stardust at some point. Are we going to return to stardust when an asteroid comes and hits this planet? That's the other big astronomy story, Dr. Salman Hameed, Mr. Universe. Everybody's worried about this potential threat of an asteroid impact. We talked about this a couple weeks ago. What is the latest? Because I know it was going to be reassessed by the people that watch the asteroid threat. Where are we at with this potential asteroid that could turn us all into stardust?
Okay, so asteroid 2024 YR4. That is the name, and it was discovered a couple of days after Christmas. It's a small asteroid. It's about, we don't exactly know its size, but it's around 50 meters or around 150 feet or so. Sort of like, the size of Olympic-sized swimming pool.
Okay.
Okay, so this is not something that's, if it hits the Earth, that it's going to destroy the planet. It's not going to be like the dinosaur extinction one. It's going to be about what they call a city killer asteroid. Mm-hmm. So, a city, it can impact that actually dramatically. And the threat of it initially, so this particular asteroid is in an orbit that takes it about sort of like, close to the asteroid belt, which is farther away than Mars. This asteroid is going around the sun, but its orbit is such that farthest it goes towards the asteroid belt, and it also comes closer to us. And every 4 years, so next encounter, so it was discovered, I think its closest encounter was on Christmas, December 25th of this year, and then the next one is going to be December 17th of 2028. Mm-hmm. That is not a threat.
Okay.
But the initial calculation suggested that on December 22nd, 2032, in some sense, not that far away. It depends upon how you think about it, because it is 2 presidential cycles. And
yeah.
Even if there is a cycle, but 2032. And the idea was that, it may come close enough that the odds initially, when astronomers calculated, were like about 1% or so, 1.2%. Then it increased
1.2% that it would hit us.
That it would hit us.
Yeah.
That's pretty high, by the way.
Yeah.
And then it went to 2%, and then it went to 3%.
Right.
And that becomes a little bit serious when it goes to 3%. However, when the thing is that you need more observations. As I said, it was just discovered. It's a small piece of rock which was just discovered in December. So you need more observations to really finesse the orbit that we know of. And in some sense, Earth has about 6,000 kilometers as its radius. So what you are talking about is that even if there is a little bit of change, it will miss it.
Right.
So it has to. So you have to really figure out. You have to precisely what the orbit was going to be. And as you can imagine, when it was found that it has a couple of % chance, there were a lot of telescopes, a lot of observations that started to look for, what is its orbit is going to be. And I just checked, actually, this morning, before preparing for that, what are its chances, and it turns out, no problem at all.
Really?
Now, the chances had actually gone to pretty much, you can think about it as 0, as far as I can tell.
So why don't you hear that news story? I heard it when it went up to 3%, but when it goes back down to 0, nobody's like, it's not as, if it bleeds, it leads kind of newspaper headline if the asteroid's not going to hit us.
That's part of the problem, right? That you hear the first part of it. And there is going to be another one in the same way, because initially you go oh my goodness, it might hit us. But then, of course, when it doesn't, that's not a big story. But I should mention, here is a way to think about it. Astronomers have created a scale. It's called Torino Scale. It's based in a city in Italy where there was a conference in early 2000s. And they wanted to figure out...
Shroud of Turin. Gran Torino, I think, was a video game or a movie. I'm trying to remember.
Yeah, I don't remember. Yeah. But anyway, so the Torino Scale was designed so that we can actually figure out how much should we panic when such news come out. So, for example, if there is a really big asteroid, we should panic if it is going to hit us.
Right.
So just because there is a big asteroid out there and we detect it and there is no chance of hitting us, then the Torino scale is 0.
Right.
No problem. And on the other side, if you have a small piece of rock, and the way they defined it was sort of like smaller than 20 meters, then sure enough, it may hit us, but it's not going to cause any damage. So let's not worry about that either.
So also 0.
So also 0. So this is a combination. So not just that if something is going to hit us or not, but something that is big enough. What are the chances of that hitting us? And then, of course, there is a range. So, for example, if you are between 20 meters to 100 meters, right? Well, that's a city devastation style. So
Like this one, whatever that was discovered on Christmas.
that's exactly right. So that has a little bit of danger, coming in. Then you have 100 meters to a kilometer. That's sort of like a regional devastation. So that's a second level. And the third level is greater than a kilometer-sized object. That is an extinction level event. And so you go like, whoa!
Yeah.
And so if those kind of objects are coming in for Torino scale, the highest one is, for city scale, it's 8. For regional devastation, it's 9. And for extinction level, it's 10. Meaning to say, if those are coming to hit you, the probability is very high. You go to Torino scale of 8, 9, and 10.
Yeah.
Okay. So where was this even at its highest at 3%?
Which I'm going to start calling the Whamageddon asteroid because it was discovered on Christmas. It's going to wham or not, cause Armageddon or not. And, the Christmas song by Wham.
That's exactly right. Thank you,
Last
Monte,
Christmas.
for bringing in Wham and George Michael.
I am now calling it forever the Whamageddon asteroid.
I think we should call every asteroid a Wham again.
No, but we can name them all after other Wham songs.
That is true. Just wake me up, okay? Before the next one comes. That's how it goes, right?
Yeah,
something
wake me
like
up
that. No. So this particular one, the 2024 YR4, this had a Torino scale of 3, which was on the yellow level, meaning to say, if it comes in, it's big enough, it can crash because it's about a 3% chance. And this has the highest Torino scale given to any asteroid since the Torino scale, we started working on that since...
Which was 20 years ago.
Yeah.
Okay.
So this is the first time that happened that it went that high. So that is what... But do you worry about it? Well, no, because... You sort of no, it's on the yellow thing. It's 3. It's not 8 or 9 or 10. So it's 3. You look at it. Astronomers also knew that they're going to refine the object if it had gone up, which was very unlikely because again, you are looking at Earth is a pretty tiny object in the sky, or in space for it to hit us. The probability was pretty low, even it was 3% at the time, but now it has gone down because of more observations. It looks like it's not going to impact us at all. But that doesn't mean that things don't hit us. This is the kind of asteroid in terms of size, potentially like the Great Meteor Crater in Arizona. It's called Barringer Crater over there. That was probably the impactor was around 50 to 100 meters across, and it happened about 50,000 years ago. And the crater is about a mile in diameter. So, if something like this hits us, can it cause damage? Absolutely, but this one is not. But if I can connect to how things are going, as I said, there's a lot of sensationalism that comes with these type of things, and you want to get good information. This is one of those things that, I give talks and I talk about sort of how do you do science communication. I also do that sort of on YouTube as well. And one of the things that we tell people is look for good resources. If you have some sensational claim, well, you want a good place to go to and look at it. And I'll try to do that as well. And usually, NASA is the best source. It's always go to the official NASA website, just check what's in there. And this is also partly from NASA website has the information. But one of the weird things, and I think this is the first time that has happened, at least to me, thinking about it, because of the kinds of news that we have been hearing in the last month or so. I was like, okay, let's check the NASA website. But there was a doubt in my mind whether the information over there is going to be there or whether the information over there is going to be accurate or not. Mm-hmm. Never thought in my life that going to NASA site, I would have a little bit of a doubt. I wonder what kind of information they will have, or if there will be information about that. Fortunately, yes, it looks like there it was. But I also double checked. So this is one of those things, how things change at a practical level. I was like, but what are the international? So because there is an international asteroid warning network. Yeah. IAWN, and which is a UN mandated network, which was designed because, like, no, okay, if something like that happens, you actually bring together, and I think that it has 19 global space agencies that are part of that. They are the ones who actually confirm data or sort of like, observations from multiple sources. Asteroid is a serious threat. How are we going to do that? I went to their website. But one of the reasons was, and I think this is in terms of a habit now we have to do that, is to look for confirmation from, and it gave me a little bit of confidence too. It's like, oh, I'm glad there are other space agencies on it as well. And there's a little bit of sadness in there because people who work at NASA are amazing. Of course, science is amazing. And it's not that in 1 month things have changed from the people who work there. But to me, there was this doubt, like, I hope their voices are going, or what they have been working on is going to be on the website, because we talked about it before. So, for example, certain websites just went dark, anything that mentioned diversity, for example, or any other things, like, So I think this was just a one, like, very small example of just a little doubt that came into my mind when I was going to that. It's not scientific. I'm just saying, when I was going in, I was like, hey, I'm looking for the NASA website. Is it still on? It was. It had the good information. It did. But I was like, but let me just double check it with the international network. And I was glad that there were other space agencies in the world that were also looking at that, and that we are not just dependent on NASA for the protection from an asteroid.
Because who knows how long that information will still be there.
And, and again, I say this with deep sadness. But I think because NASA is also considered, in Pakistan and everywhere, by the way, the coolest agency.
Totally.
People
wear the merch.
Exactly. Like, they would have stickers, and I still get, in fact, I met somebody last week that come from Pakistan. This was part of sort of like, a startup groups and things like that. And the guy came in and said, oh, astronomy. He said, I have a 10-year-old and he's really into astronomy, and he wrote a letter to NASA. You hear so many times.
Yeah. I went to Wallops Island, the rocket launch site near D.C. in Maryland, and I got a raincoat with the NASA logo on it. And whenever I wear it, people are like, are you an astronaut? And I'm like, I might be.
No, but it's also, people just write a letter to NASA. Because,
Dear NASA.
Dear NASA, because they think, because of the reputation, because of the respect that people have and things like that. So, and I hope it will still remain, or I hope it will not be devastated the way we think it might. But if the next asteroid is coming in, who may actually be hitting us, we do need missions like DART mission that had gone in and hit an asteroid. It was a sort of like, crashed on it.
To prove we could do it.
To prove we could do it, because if this asteroid, if it turned out that this was coming in to hit us, then we would have needed a mission like DART to go in and kinetically impact it and do that. And for that, you need people who can actually do that. And just, I have to add this, and competency doesn't mean just white people. I think competency means everybody, and diversity is also crucial because you bring in different perspectives. I just have to add that.